I'll hit the record then. All right. Hi, Allie. Sorry you missed our class today. We had our quiz, so make sure you take it when you come back. And did you get my email? Did you get my email?
Yeah.
All right. It was on integrals, we call them antiderivatives and derivatives, and then one of those visualizations of the integral, where you have given a graph of the slope, and then you pick the graph that it corresponds with. So that's how you can prepare, and I sent you a quick email on that, so hopefully you got it. Let me know if you didn't, and we'll figure out why. I sent it. Okay, here's our topic for today. We're doing the area under the curve with those rectangular and triangular shapes, and I'll check your assignment when you come in next. So today we're going to just build on that. All right, so we're going to look at the area under the curve again. This time, the curve is not going to be straight line, it's going to be curved. So we are going to look at one that looks like this. So if you would draw something similar, I'll call that y equals x squared plus 1. So it's the old smiler raised up 1. Notice I've drawn it kind of large and stretched out because I'm going to write under it. So don't be stingy with your picture. Spread it out a little bit. All right, are you up with me yet?
Almost.
Okay.
Okay.
All right, I'm going to talk about the area under this curve, but this curve goes forever, so I have to give you an interval where I'm interested in this curve. So I'm interested in this curve on certain values. So I'm going to look at it between 1 and 3 for the x value. So 0, 1, 2, so 3. So I'm going to look at the area under this curve right here. So as I do that, please, Allie, take notes on this as you're watching this video. And as I do that, I'm going to shade that in lightly so that I can eyeball it well. I should have written it even bigger than that, so don't be afraid to stretch this out. I think you'll be all right with the drawing I made. So I want the area under the curve on this interval from 1 to 3. This is the name of our function. And I'm going to use a set of boxes or rectangles to find that area. It will not be exact. So here, as you can see, a rectangular area is never going to match this curve exactly. So that makes sense because the rectangles have tops that are straight. So we're going to lose some in our approximation, but again, we're going to approximate this area under the curve today. And we're going to build to a point where we do get it exactly. So just to kind of to whet your appetite. All right, so let's go ahead. And I'm going to tell you, and in the assignment, which I'll show you in a minute, Allie, notice I've told on each one I've told you how many rectangles to do. So the example I'm going to show you is going to be 4 rectangles. All right, so these are the parameters for the problem. The name of the function, the interval I'm interested in, and how many rectangles. Is that showing up? All right, in order to do this, and I'm going to divide this equal into equally with 4 rectangles of equal width. So to figure out how wide each one will be, I take the interval 3 and minus 1 and divide it by 4. And that tells me that each of my rectangles is going to have a width of 1/2. So I'm going to go from 1 to 1.5 and draw a rectangle, or draw a straight line. I'll make it into a rectangle in a minute. So do you see where I am at 1.5? Then I'll actually write under here, this is 1.5. Then 2, at 2, And then at the next half, we'll be up to 2.5, and then we'll be at the end point 3. So do you see how the width of these almost rectangles are the same? They're each 1/2 in length. So you're going to have to make that calculation for the width. It depends on your interval and how many boxes. So you will always take this number minus this divided by this to get the width of each rectangle. You with me? Tracking? Okay. All right, now we have to make rectangles out of these, and I'm going to use left-sided rectangles. Sometimes I just call them left rectangles. And what that means is I have a choice. I can make a rectangle from the left by going straight across or from the right. So I'm going to draw one from the left and one from the right. You won't be able to do both on your paper. So if I draw it from the left, I'm going to start at the left side of the first box and go like that. Now if I was doing it from the right, I would have taken this point and gone actually above the curve. Do you see that?
Which one should we?
We are going to do left-sided rectangles all today.
And for homework too?
Yes. Yeah, these are all left-sided. I'm going to put use left rectangles so you can add that to your homework list that you've started. Did you get that all down, that homework?
Yeah.
Oh, good. You write so fast. Okay, so I'm going from the left and I'm going to make the top of the box there. That's rectangle number 1. Rectangle number 2. The point on the left of the number 2 is right there. So do you see where the top of that one will be? Mm-hmm. Then left rectangle number 3 and left rectangle number 4. So when I find the sum of the areas of these 4 rectangles, will my approximation be above or below the true area under that curve?
Below.
It will, because we're losing those little slivers right there. Now if the graph had gone this way, and don't write this down, notice, say I was doing left rectangles under this curve, notice the, these are left rectangles, sorry. But see, like this, see how my left rectangles, it would have been formed if the curve went in this direction. Would this approximation be more or below? More. It would be more. So it doesn't all, just because it's left does not mean that it's going to be below. It just depends on the slope of your graph. All right, so now we just get the fun of just calculating this. So each one, so there's going to be 4 rectangles. So I'm going to fill in the blanks. 1, 2, 3, 4. So the first rectangle is how wide, Bailey?
1/2.
All right. And how tall? We're going to go find out the height by looking at that point. And that point is on the curve y equals x squared plus 1. So how can I find the value of this point on this curve? Do you know?
Plug in the x.
Yeah, and what value are you going to plug in?
1.
Right, so you're going to put 1 into that. So right now I'm just going to write it like that. That was an easy one, but the next one won't be as obvious. So the next box is how wide?
1 point, or it's still 1/2.
Right, and this time, just tell me the expression I'll have to evaluate to get this point.
You plug in 1/2 for x.
1.5?
1.5 for x,
So 1.5 squared
plus
1. Notice we took the x value of that second box on the left and plugged it into this function to get the height of the box. And the third, 0.5, I got that part.
Times 2 squared plus 1.
Right, that was not bad. And lastly?
0.5 times 2.5 squared plus 1.
2.5 what?
Squared plus 1.
Alright. Alright, so I'm not going to take the video time in order to calculate that, but you'll need your calculator to do these. I mean, you could do them by hand, but you're welcome to use the calculator on this part. And this one, comes out to 8.75 when you do that. When you actually plug all that in and simplify, you'll get 8.75 units squared, whatever the units are, since it's an area, units squared. So, any questions about that? All right, how much time do we have? Like 3 minutes?
Yep.
3 minutes? Okay. What I'm going to do is stop there, and I'm going to give Bailey the answer to the first one. First of all, we're going to show you the homework, Allie. You might have to use the, do you have the zoom in? It might be fine. It always shows up even better on the computer than it does on that little screen. Does it look like it's showing up?
I think so.
All right, so Allie, we're going to do the same thing with 4 examples starting now in class and for our assignment. So I'm giving you a function, an interval, and how many rectangles to use for your approximation, and use left rectangles. And we'll take it from there next week and we'll do more with this. So this is sort of building towards something that's going to be meaningful. All right. I'm going to give you the answer to number 1 so that you can know, Allie, if you're on the right track. So let me get that answer. It is, I think it is 13. All right, I'll send you an email if that's not the right answer. But it looks like from what I did last night, I got 13. So. All right, Allie, we had a short class because we had the quiz, so that's all for today. I hope you're feeling better, and see you on Monday, hopefully. Bye.
Bye.